In this opportunity, we're going to show some case scenarios when working with member end releases. If you're not familiar with this topic, we have a separate video with a proper introduction to this subject. We are going to study this model you see here, a wooden platform with supported steel beams. Let's see. Here's my platform model. Some of you may be already familiar with the properties of this model. Just to show you the I-beam I'm using for the steel members. Materials, 1 for steel, my beams, 2 timber for the platform. Is fully fixed at the ends of these beams to a wall that is here, supporting the platform. And let's just take a look at the member local axis of each member. So I can know which is my I and my J node. With the member axis orientation tool, I can display my local axis for X, Y, and Z. And I have just created one folder called beams just to take a look at the beam elements. So I can see X in this direction for this beam, meaning that this is my I node and my J node. And the other local axis follow the right-hand rule. In the case for this beam, where X is pointing to this direction, this will be my I and my J node. And you can also use the shrink element for visual checks to see the extents of your members. As you can see, I'm using physical elements for each of the beams. With this known, I can proceed and take a look at the loads, but we will focus on some of the load cases I've defined. If I display my vertical point load, I can see it's a minus 200 kilonewtons at the edge of these beams. And I have a horizontal load as well, about 5 kilonewtons in the x positive direction. And you can see the global coordinate system here. Now I can stop displaying the loads, and I would like to see the member end releases for all these beam elements. With the elements selected, I can go to the spreadsheet window, then to the member spreadsheet, and I can see the releases in FX, MX, MY, and MZ. All of them are fixed, meaning that they are not released, and this is by default every time you create a member. As a user, you can always modify this and maybe set different scenarios. In this case, we're gonna take FX for the first beam, and I'm gonna release the far end on the right for that beam, meaning the J node. So it's fixed in I and it's pinned, which means released in J. So if I run a linear static analysis for the load cases only, I see it comes with a clean solution. So the model is stable. But remember, we still have the wooden platform, which gives some more stiffness to my whole system. Right now, I'm focusing on the beams. Let's take a look at the deflections. Just for the vertical point load, I can see it deflects a bit further in the ones where FX is released. So remember, this end is released from the axial force, and this one isn't. And you can better see it if we see the axial force diagram. And there's some axial force coming from this point, and it comes to 0 here. You can double click this member just to see it in more detail. So it comes to 0, and it's not transferring the axial forces to the other beam. So it's basically disconnected. And actually, in the deflections diagram, you can see it quite clearly here. It's showing that some kind of disconnection. But remember, this node is also connected to the wooden platform. Now, if we go back to the spreadsheet window, and for this occasion, we set this as fix, as it was set before. Set this as pin for all these cases, for the first and second beam element. So just to let you guys know, if I go back to the geometry window, to the member end releases, I see I use the spreadsheet to set this as released pin from the I and J node in moment Y and Z, same as this beam here. And I have this one, this other, all fix for comparison. If I run an analysis, it is still running without issues, so the solver is okay. Now remember again, I have the wooden platform here, which gives some stiffness to my whole system. And let's start looking at some of the results. For the vertical load, I can see I have more deflection. And even in the other directions, I'm getting some slightly more deflection when looking at this point here compared to the other. If we take a look at the moment diagrams, we can see some further differences when looking at both supports from my platform. Moments in Y and Z are quite small here, so almost none. If I look at the other load case, I can see as well some differences. So it's showing 0 here, which is expected since I have released the moments in X and Y for these two elements. Thank you for watching, and for more tutorials and videos, please subscribe to our YouTube channel.